Welcome to your final exam. First, we're going to talk about a new version of the SEIR model, one that includes births. Now, when we include births, which means births of non-immunized or susceptible children in immunological models, new effects appear. Here we're going to try that out using the SEIR model. You might remember this from our earlier unit. This is just the SEIR model with an added stage of being exposed to the disease but not yet infectious. In other words, a person who's in the E category here is infected but can't yet spread the disease to other people. Now we've introduced a birth rate, which means adding people into the susceptible pot, and a mortality rate. All compartments S, E, I, and R have the same mortality rate, however. So this means that the disease isn't life-threatening since people across the board, regardless of whether or not they're infected, die at the same rate. This is a model that does have immunity, so that means we don't have a cycle as we did in some of our other examples. Instead, we just have a straight shot from S to E to I to R. Now, as we did before, we'll call our total population N, but in this case, N is not a constant. Rather, N is a function of time. It's still equal to the sum of S, E, I, and R, but the sum is going to change over time. Now, since N is no longer a constant, we need to make sure that we compute the number of infections per day correctly. It isn't just going to be some constant times I times S anymore. Let's build up the equation together. So we're going to start with the number of times any person comes into contact with any other people per day. So that's just equal to contacts per day. Then in order to get the number of contacts per day of a person with susceptible people, not just any people, we modify this by multiplying by a factor of S over N. So this is just the fraction of the total population that is susceptible. And of course, this is a function of time as well. Then if we want to change this expression to equal the number of infections spread by each infectious person per day, then we multiply all of this by the transmission probability. Now lastly, to get the total number of infections per day, we multiply this by I, the number of infectious people. Now what we want you to do in the code is to implement the SEIR model using the forward Euler method. As always, we've given you the important constants that you'll need to use, including the birth rate and the mortality rate, and of course, a set of initial values as well. And down here in the for loop, we've included the standard equations for the SEIR model, but we haven't taken into account births and deaths yet, so that's your job. Good luck on the first problem of your final.